Good afternoon. I'm going to go through the homework questions that I uploaded yesterday. So these were our quadratic equations by substitution, or they're sometimes called linked quadratic equations, because they're two different equations that are linked together by the same pattern. Right, so for the first question there, the first thing we have to do is solve the quadratic equation in x. So we're solving x squared plus 10x plus 21 equal to 0. We can use factorizing, or we can use the minus b formula. And the two answers that we get are that x is equal to minus 7, or x is equal to minus 3. Now, the second piece of information is this messy looking equation in y, but we can see that it's following the same pattern, so that x, everywhere we had x here, we now have 2y plus 5 here. So we can say that x is equal to 2y plus 5, because it is. And that means that when x is minus 7, 2y plus 5 is minus 7, 2y is equal to minus 12, and y is equal to minus 6. That's one of my answers. And when x is equal to minus 3, 2y plus 5 is equal to minus 3, 2y is equal to minus 8, and y is equal to minus 4. Okay, that's question 1. Exactly like we wanted it. Now, that's handy if they give you the initial quadratic equation, but a lot of the time, and in our notes, they won't do that. They'll just give you something that looks like this. And it's up to you to spot that this is a type of quadratic equation. Of course, we could multiply out the brackets, right? We could square out these brackets and multiply them out and get our equation in y. We could have done the same thing up here as well. But this is a shortcut that allows us to answer questions like this really quickly, because we can spot that this is a quadratic equation it's following the pattern of a quadratic equation, with the same thing in every spot. So the first thing I'm going to do is I'm going to say let x equal to 3y minus 1, and then I'm going to solve x squared plus 13x plus 40 equal to 0, which I can do by factorizing. X plus 5, x plus 8 equal to 0, so x is equal to minus 5, or x is equal to minus 8. And then I use some ink there. Just move this aside for a second. And then I use the fact that I said that x is equal to 3y minus 1. So when x is equal to minus 5, 3y minus 1 is equal to minus 5, 3y is equal to minus 4, and y is equal to minus 4/3. When x is equal to minus 8, 3y minus 1 is equal to minus 8, 3y is equal to minus 7, and y is equal to minus 7/3, minus 7/3. And those are my answers. That's everything that I wanted. Okay, now let's go back to what we were doing in the notes. And this is the equation that we have down here. So this equation doesn't really look like a quadratic equation, but what we can spot straight away is that there's a repetition of the same expression, y squared minus 2y. So y squared minus 2y is repeated. And when you have a repeated expression like that, it makes our lives much easier if we use substitution, if we let x equal to that repeated expression and substitute, solve, and then find the y values. So let's look at what that might look like. So if I replace y squared minus 2y with x everywhere in that equation, I get x minus 11 plus 24 over x equal to 0. So this is now what I'm trying to solve. That doesn't look particularly familiar either, but we do know what to do when we see fractions. Whenever you see a fraction in an equation, you multiply across by the common denominator. So I'm going to multiply everything by x. That means I'll multiply here by x, here by x, and here by x. Even the 0 gets multiplied by x, but 0 times anything will just be 0. And what happens is, we chose it so that the fraction would cancel. And when we rewrite this, we get x by x, which is x squared, minus 11 by x is 11x, plus 24 equal to 0. And now I can solve this quite easily. I'm looking for something that adds to give me minus 11 and multiplies to give me a plus 24. The signs must be the same and they must both be minus. 8 and 3. So either x is equal to 8 or x is equal to 3. And then we use those two answers with this fact here. So when x is equal to 8, y squared minus 2y is equal to 8. Oh, I have another quadratic. I'm actually going to get 4 answers for y from this. So y squared minus 2y minus 8 is equal to 0. And I factorize that. Y minus 4, y plus 2. So I have y is equal to 4. And y is equal to minus 2. And when x is equal to 3, y squared minus 2y is equal to 3. So y squared minus 2y minus 3 is equal to 0. And I can factorize that. Y minus 3, y plus 1 equal to 0. So y is equal to 3. And y is equal to minus 4. Now, what we have there is all the solutions. Each of these numbers, each of these 4 numbers, if you inserted them where y is here, we would get 0 when we calculated that expression. That's what the solutions mean. It means that when you sub in those values, your equation will be true. It will be a true fact. So we got 4 possible solutions. 4 solutions. Okay, I don't want to move on from this until you've done a little bit more practice with some difficult ones. So in the book, rather than doing any more notes, I'm actually giving you quite a lot of homework to work on, and we'll go through the solutions of that homework tomorrow. So the homework that I want you to do is in the book, page 53, question 5, all parts. So they can be a little bit long and confusing. So that's all I want you to work on for this evening. I say all, but there's actually quite a bit of work in there, and we'll go through the solutions tomorrow. Okay, thank you very much, and I'll talk to you tomorrow.